So piecewise functions, you've got two ideally things that you need to address when you work on piecewise functions, probably actually more, but big from the very beginning. So what I always do, and this is maybe a little overkill for some of you, but I'm going to, just so we know exactly which function I'm talking about, I'm going to highlight function number one color, and function number two, the other color. Now, the reason I do that is so I can stay focused on the difference between the two functions, and because I'm going to carry on this color coding idea all the way through before I even get to the algebraic portion. So for this says x is less than or equal. So x is less than or equal to 5. So that means all numbers including 5. So if I go down here to the number line, that means I open at 5. It says less than, which means everything to the left of 5, all the numbers where it's getting smaller, but also including the number 5 on your number line, if you remember this from inequalities back in Math 1. Now, your blue function, or my blue function, says x is greater than 5, but also less than or equal to 10. And that basically means x is between 5 and 10, not inclusive of 5, but inclusive of 10. So again, we know we're going to go between 5 and 10. At 5, the number 5 does not count because that's not that equal to, but it's everything to the right all the way to our 10, and 10 does count for the blue or second function. So with that said, if I look at f of negative 2, remember that this is function notation, and this number is the number that is plugged in the place of x. So when we're solving function notation, that negative 2 is going to go anywhere there is an x, if there is an x to solve for. In this case, we're trying to decide, is that negative 2 in the orange function or in the blue function? So our negative 2 is going to be down here, right? Negative 1, negative 2. So this is our negative 2. That's definitely in our orange function because it is less than 5. So that means that this one we are going to plug into our orange function. So we're going to go negative, and then we have our x value minus 4, and then we're going to solve. In this case, we're going to plug in that negative 2. Don't leave out the negative on the outside. So that double negative makes that a positive 2 minus 4, which is going to give me a negative 2 as my answer. So when x is negative 2, y is also negative 2 for this function notation, or this function when it is drawn, this piecewise function. For the second one, we're looking at 7. Does 7 fall between 5 and 10, or is it less than 5? So we're going to go find 7, just 6. This is 7. So it is in our blue function. So we're going to use our blue function, or the second function. And again, that is going to mean we're going to plug in that 7 in the blue function. So that's 2, open parentheses, squared, minus 7. And we're going to plug in there a positive 7. Remember our PEMDAS, or our orders of operations, we're going to do our exponents first. So 7 squared is 49. So that means I have 2 times 49 minus 7, and then 2 times 49 is 98. So 98 minus 7 is going to give me 91. So when x is 7 in this piecewise function, then y is going to be 91. And again, that's a throwback to your function notation, where f of x is the same thing as y. So whatever the output is, that is the y value versus f of, and when we plug in something here, that is the x value. So if you're looking at them as coordinates for our orange function, it would be when x is negative 2, y is also negative 2. And for our blue one, when x is 7, y is 91. All right, one more example for this video. We're going to color code our two functions again. So I'm going to make the top one purple. Does that one show up on the video? Yep. And then I'm going to make the second one pink. Change of colors for fun. So again, we're going to look at our number line. We're going to go to, this says it's 14 if x is less than or equal to 0. So at 0, that equal to means that I am going to color that in because 0 does count, and it's less than, which is everything to the left. So all numbers that we're going to find to the left, and I put an arrow because it's indefinite that way, are going to be our purple function. Our pink function is 0, but there's not an equal to, so that just means that's our parameter, but not actually 0 because 0 is purple. And then x is less than infinity, and that's a positive infinity. So that means it's going to go on forever to the positive side. So we're going to look at our functions. So the first one, it says f of -5. So -5, we're going to go find -5, which is here. Sorry, there, -5. And that is in our purple function. So we know this is going to be purple. And then from here, we are going to plug in -5 into our function in the place of x. But here, there is not an x. So that means there's no math to be done. This one's beautiful. The answer is 14, and you are out. So anytime the number in this piecewise function is equal to 0 or less than 0, your answer is 14. You're done because there's not an x value to plug in. The output is already solved for you. The second one, we have f is a positive f of 1, positive 1. So we're going to go look for that positive 1, which is going to be after our 0, right? So this is our positive 1. And that is in our pink function. So we're going to use our second function. This is just coincidental that these two happen to be in order set up like this. But again, as a review video, just want to make sure I catch on to the basics. So we're going to take 1 and plug it in the place of x for our pink function. Now this one's different because there are two x's. So it's x squared minus 9 times an x. And I put those parentheses to make sure I don't mess up positives and negatives and leave things out. So the only thing I'm replacing is the x. That 1 actually replaces the x. So 1 squared is going to give me 1 minus 9 times 1 is 9. So our answer is -8. So when x is positive 1, our y value is going to be -8. And on the previous, when x is a -5, our y value is going to be 14. So your number one thing you have to do is, 1, figure out, differentiate, probably what I would do first. Then figure out where this number falls in these domains. These are called little domains because they are x values. And that's why we can put it on a horizontal number line. So you're going to look to where it falls there. And if the number line helps you, draw it. All right, guys, that's the basics for piecewise functions. Hopefully that helps.